ever get that feeling?
Yeah.
Like you're seeing the same pattern pop up in like totally different places. Almost like there's this hidden code connecting, math and music.
Yeah.
Or even just the way we think.
Yeah.
Well, today's deep dive is all about that feeling. The fascinating concept of isomorphism.
Isomorphism. It's a pretty powerful idea, isn't it?
Yeah.
It essentially means same shape.
Same shape, I like that.
Yeah. So it's about recognizing that two things, even if they look completely different, like on the surface, can share the same underlying structure.
So we're not just talking about like a superficial resemblance here, right?
Yeah.
This is like deep down, like a blueprint versus the building itself.
Exactly. It's all about that blueprint.
Look.
And our sources today actually take us on this journey through isomorphisms across mathematics, computer science, linguistics, and even psychology.
Wow, that's quite a range.
It is. And what's fascinating is how recognizing these same shapes, these isomorphisms, can lead to breakthroughs and help us solve some really complex problems.
Well, let's start with mathematics. Our source dives into isomorphic groups, which sounds a bit intimidating, to be honest.
Yeah, it can sound a bit jargony, can it?
Yeah. So can you break it down for us?
Sure. Imagine you've got two sets of building blocks.
Okay.
One set is red, the other is blue. You can build the same exact structure with either set.
Yeah, the color doesn't really affect how they fit together.
That's exactly the point. It's the relationship between the blocks, that blueprint, that matters.
Right.
In math, this means that two groups can be structurally identical, even if their elements are represented differently. And this leads to some really amazing insights, actually.
Like what?
Well, did you know that there's a way to map the structure of one group onto another?
Okay.
It's like creating this perfect blueprint overlay. It's called a homomorphism.
A homomorphism? So wait, it's not just about recognizing that they're the same shape, but it's about understanding how that shape transforms from one thing to another.
You got it. Precisely.
That's so cool.
And this is huge in math, like humongous.
Yeah.
It allows mathematicians to study the core properties of structures without getting lost in the superficial differences.
Right.
So they can take what they learn about one group and apply it to another, even if they look completely different.
Okay, I'm starting to see the power of this same shape thinking. It's like working smarter, not harder.
Absolutely, yeah. Efficiency.
So where else does this pop up? Because I have a feeling it's not just math, right?
No, you're right. It's everywhere.
Yeah.
How about we jump into computer science?
Okay, I'm ready.
All right. In computer science, we run into something called graph isomorphism.
Okay.
And to illustrate this, think of two maps of the same city.
Right.
One is your typical street map, the kind you unfold.
Yeah.
The other is a subway system diagram.
Okay, got it. And visually, those are totally different.
Right. Completely different. But here's the thing. They both represent the same connections between points.
Okay.
Just in different ways.
They just show it differently.
Exactly. Now imagine you're building a social network,
right?
Like a massive one. You have millions of users and you need to represent all their connections.
Right.
A simple list of all those connections, it would be a nightmare to search through.
Yeah, trying to find someone's friends of friends would take forever.
You'd be there all day. But what if you represent that social network as a graph?
Okay.
Each point is a user, each line a friendship.
Right.
This graph, while looking completely different from a list, is actually isomorphic to it.
Interesting.
They contain the same information, just structured differently.
So finding the right shape, like switching from a list to a graph, can make a huge difference in efficiency.
Absolutely.
It's about picking the right tool for the job, even if it looks different from what you're used to.
Couldn't have said it better myself. That's exactly the beauty of it.
Yeah.
Understanding isomorphism, it helps computer scientists optimize algorithms and data storage. They can choose the most efficient representation based on what they need to do with the information.
This is blowing my mind. I never thought about it this way.
It's powerful stuff.
Okay, I'm ready for the next challenge.
Sure.
What about linguistics? How does isomorphism play into language?
Well, our source, it points to this really fascinating concept called isomorphic grammar.
Isomorphic grammar?
Yeah, and it turns out that the subject-verb-object structure, like the fundamental building block of sentences, it exists in a ton of languages.
Wait, really? Even if the word order is totally different?
Exactly. Like, take English and Japanese.
Okay.
They have wildly different word order, but both languages fundamentally rely on that subject-verb-object relationship. So it suggests this deeper shared structure beneath all those surface variations.
That's really interesting. So even though languages sound and look different, they might share like deep grammatical similarities.
Yeah.
That could be really helpful for, things like language learning or translation.
Absolutely. Recognizing these underlying similarities can help us bridge those linguistic divides.
Right.
And understand the human capacity for language in a whole new way.
Okay, I'm convinced. Isomorphism is everywhere. Math, computer science, language.
Yeah.
But our final stop is perhaps the most intriguing.
Oh, yeah.
Yeah. How does this concept apply to how we think?
Well, this is where things get really meta.
Okay, I like meta. Let's get meta.
All right. Our source talks about something called metaphorical isomorphism.
Metaphorical isomorphism.
Okay.
And essentially this means our mental models often mirror real-world systems.
Okay.
Even if the connection isn't literally true.
Can you give me an example? Because I think I'm getting it.
Sure. Think about how we often describe a complex project as a tangled web.
Oh, I do that all the time. See? There you go. That's metaphorical isomorphism in action.
Really?
You're using a familiar image, a tangled web,
Yeah.
to represent the complexity of the project, even though it's not literally a web.
Yeah, right.
Or think about how we often talk about our minds as containers for ideas.
Oh, yeah.
It's a helpful model, even though, again, it's not physically accurate.
So this idea of same shape, it's shaping how we understand and interact with the world around us, even subconsciously.
Exactly. It helps us grapple with those really abstract concepts by relating them to something familiar.
Wow. So big takeaway today, isomorphism. It's more than just a cool concept. It's this fundamental principle that connects like all these seemingly disparate fields and helps us understand the world.
And the journey doesn't end here. What's really exciting is that we've only just scratched the surface.
Right.
What other hidden isomorphisms are out there just waiting to be discovered?
That is the question, isn't it? What seemingly unrelated things in your life might actually share a deeper structure?
That's something to think about. This has been an awesome deep dive. Thanks for joining us.
My pleasure.